Virtual machines were the unit of cloud computation for many years. Amazon Web Services pioneered the democratized model of allowing anyone to deploy a service to the cloud, running on a virtual machine on Amazon's servers. After virtual machines, containers have become the unit of scale in the cloud. Today, we break up our virtualized servers into even smaller units of computation called containers. Today, the unit of compute is getting reduced even more with the introduction of serverless architecture. Serverless architecture started getting talked about after Amazon Web Services released a service called AWS Lambda, which allows users to have pieces of code run in response to events. Programmers write a function and hand it off to Amazon, and Amazon will run that function call and only charge the programmer when the function is actually called. This is in contrast to the cost model of containers or virtual machines, which users pay for even when these machines are running idle. Today's guest is Austen Collins, and he believes that serverless computing is the model for the future. And he created a company called Serverless around this idea. His company, Serverless, provides an application framework for building applications exclusively on Amazon Web Services Lambda. If you enjoyed today's episode, please share it on Twitter or Facebook. Tell your friends about your favorite episode. You can also send me an email at softwareengineeringdaily@gmail.com. I'm always looking for new show ideas. I want to know what I can improve on, and I want to know what you're thinking. So just send me an email. Tell me about yourself. Tell me about what I can do better. Thanks for listening. I had a crazy idea a couple weeks ago. It's a photo sharing app that only has pictures of cats. When I finish my photo sharing cat application, I will be deploying it to Linode because Linode is the fastest hosted Linux provider. I don't want to get locked into a proprietary platform that's going to overcharge me as soon as my app gets popular. I just want a fast Linux server with simple pricing. Go to linode.com/sedaily and get $20 in free credit today. Plans start at $10 a month, so my free $20 will be plenty to launch my cat photo sharing app. Once I need to scale, I can use tools like node balancers and backups, and Linode has built-in dashboarding and metrics so that I can see the traffic to my Linode servers, and I can understand how many of my users are posting cat pictures and looking at each other's cat pictures. Go to linode.com/sedaily and get $20 in free credit today. The plans start at $10 a month, so it's a great deal. Thanks to Linode for sponsoring Software Engineering Daily. Now let's get on to this episode. Austen Collins is the founder of Serverless, an application framework for building applications exclusively on Amazon Web Services Lambda. Austen, welcome to Software Engineering Daily.
Hi, Jeff. Thanks for having me.
What is serverless computing?
That's a big question. This is something that people are debating all around the internet right now. I actually stay away from precise definitions. To us, it's more of a theme and an ideal. And it's something that we will be constantly chasing for quite a while. But I think in a very general definition is that the developer does not have to think about servers even though they exist.
So to put it in more tangible context, for many years we have been using virtual machines as the unit of computation and the unit of scale. Containers have become the unit of scale today. So in the past, if Twitter is scaling up or down based on lots of users, high traffic, they would have used virtual machines to spin up new instances of their monolithic application in a virtual machine. And then more recently, we think of containers being the unit of scale. And you have these smaller services that are containerized. So what has changed as a result of that overall shift from VMs to containers?
Right. Well, I'll speak to, I'm actually not a container expert, but I am a serverless expert. Back in 2014, when I was going to get into containers, that was right when Lambda came out. And I actually just held off on containers and doing a deep dive on them, because Lambda was something that spoke to me right from the beginning. And I'll tell you sort of the critical differences of Lambda, and this will help answer that question you had about what is serverless computing, or what qualities do we associate with that term today. And first off, with serverless computing, with a serverless architecture that's built on Lambda or any of the new functions as a service products like Azure Functions or Google Cloud Functions or IBM OpenWhisk Actions, the container is still sort of the unit of scale, but we're more associating the unit of scale with actual functions, which is a lot more granular than I think even microservices or containers can be. And that comes with some implications, which we can discuss in a bit. But also the other qualities, the other differences are this much more efficient pricing model that AWS has introduced for Lambda, and that is pay per execution. So there's a vast amount of underutilized resources out there that I encounter every single day when I'm talking to enterprise users of the serverless framework. And with Lambda, there is no such thing as underutilization. Whereas a company may spin up a whole bunch of EC2 instances and never deprovision them, and I see that all the time. But with Lambda, they don't have to worry about any of that stuff. They only pay for what they use, and they don't have to take anything down when they're not using it. So that's great. And overall, there's no administration in general, which is I think where the serverless term is really relevant. So I'd say those are the big differences, and that's the big shift that we're seeing right now.
Explain what happens when I make a call to an AWS Lambda function. Like how does it look in my code, and what is the request response model when I'm making a request to Amazon to call this function, and then they send me back a response? What is happening on their end?
I don't have all the information there. Amazon is very secretive about what happens behind the scenes. But I do know that when you upload your code to AWS Lambda, you're going to upload a zip file containing your code and all of the dependencies it needs. Lambda doesn't install anything. For example, if you have a Lambda function written in Node.js, it's not going to install any dependencies that are listed in package.json. It's only going to run everything that's in that zip file. And when you upload your code to Lambda, it's going to be put on, I believe, AWS's own S3 account or system. And whenever that code is first called, they're going to download it, unzip it, spin it up into some type of worker machine, probably EC2. Build the environment, like a Node.js environment before that, and then execute the code. And they do all of that really fast, especially in the case of Node.js. They do it so fast that it's sufficient enough to handle web requests. So something where you need a response time around 250 milliseconds or less.
So what are some examples of things that I would use AWS Lambda for? What kinds of requests would I want to use it for today?
Everything. What we have with Lambda is incredible convenience. And because of that convenience, developers are just looking to use it for everything they can. So in the early days, I believe it was used for more data processing, hooking it up to Kinesis streams, DynamoDB streams. But I think something that JAWS, which was the original name of the serverless framework, helped point out is that this could be used for all types of things, especially REST APIs. So we see, lots of data processing use cases, lots of backend services now being built on Lambda, lots of REST APIs, like, for example, just a user's CRUD implementation. People are converting, their entire web applications over to Lambda. In addition to that, we see lots of really cool creative use cases. I think that there are video encoding Lambda functions that people are building. For example, they may have one Lambda function that orchestrates a whole bunch of other Lambda functions, and each of those other Lambda functions can process one frame of video or compress it and then put them back together. And again, this all goes back to Lambda's inherent convenience. The fact that you don't have to administrate all this stuff. You could spin up a whole bunch of Lambda functions concurrently rapidly to do all types of tasks. It's really leading everyone to do everything on this, and also not just business logic, but tons of DevOps logic, which is great. So tons of log analysis, security audits, data replication across regions, all types of stuff. And it's really cool how you could connect Lambda functions that have business logic in them, with Lambda functions that are also doing DevOps. And it's all event driven, which has helped making this possible. So the short answer is really everything, and it's just because it's so convenient that people want to use it for everything. And as the features grow for Lambda, I think it'll soon be able to handle almost every use case there is.
So let's think about it from the perspective of prototypical introductory application. So like a to-do app. So let's say I have a web application where I want to be able to create new to-dos and store those to-dos and then, delete them after I've done them. How would I architect that using AWS Lambda? How would I build it so that every time I am interacting with the remote server, instead of thinking in traditional terms of a VM or a container, I've re-architected it to think in terms of Lambda?
Right. Okay. So that's a typical sort of CRUD example. You're probably just going to make a REST API with create, read, update, delete operations for that to-do app. And there's a few ways you can implement it. Again, it's Lambda is very flexible, and we see people employing different patterns when it comes to rolling out their Lambda functions and how their code is organized into those Lambda functions. So what I see with the framework are three patterns, and these names, I don't know, these names might be confusing, but this is how we're referring to them right now. First off, we see the Nano service pattern. And this is you write one Lambda function that does one job. So in your to-do, if you have a tasks data resource, you'd have one Lambda function for create, read, update, and delete. So that would result in 4 Lambda functions, and each of those are focused on one specific job. And people do this because they love the separation. It's much easier to debug because they say, this Lambda function is supposed to do X. It's either going to do X or it's not. And also, it leaves you in a super agile position. And a lot of this is because AWS Lambda is inherently a microservice platform. And because you're spreading out your code across all these independent microservices, it just leaves you in a very agile position. So, for example, in this to-do application, you'd have 4 Lambda functions, and then you hook that up to Amazon's API gateway service, and you give each of those Lambda functions their own REST API endpoints. And at any time, you can go in and modify one of those operations, either the create task or the delete task Lambda, independently of the larger system, of the entire application, which is great when you're in production because I'm only going to touch this one specific component of my application, and it's not going to affect anything else. And when you're in production, and you have a lot of users, that's a great thing. And that's what the Nano services pattern is perfect for. Also, we see people employing what we call the microservice pattern, which is they may have a data resource, like a task in your example, and they may put all the operations for that data resource in a single Lambda function and hook that Lambda function up to multiple API gateway endpoints. So one HTTP endpoint for the create, read, update, delete operation, all pointing to the same Lambda function. When you hit one of those endpoints and it executes the Lambda function, you can actually parse the API gateway information, detect the route or the path or the method that the person used, and perform the correct logic. And the value that this gives you is that you're not going to have the 4 separate Lambda functions, which is really nice for debugging. But you're going to have a slightly bigger Lambda function, which is still not as hard to debug as a monolithic application. But people are doing this because they want less Lambda functions to manage, And when you're developing with Lambda, you will end up with a lot of Lambda functions if you're building a complex system. But also they want to optimize their Lambda functions for any cold start performance issues. Because when you first call a Lambda function that hasn't been called for a few minutes, there will be a bit of a cold start delay, depending on the memory size that you have of your Lambda function and what that Lambda function is doing, and especially what languages you're using. So by putting more logic in a Lambda function, there's a higher likelihood that Lambda function will be called more, and it will always stay warm and be more responsive, which is important for if you're handling web requests in particular. So that's the benefit of the microservice pattern. So we have the Nano services pattern, the microservice pattern, and again, I'm not, these are just temporary names, trying to inherit some of the patterns with those terms when I talk about these. But lastly, there's a new pattern that we've been trying to pioneer a little bit ever since we saw that GraphQL, Facebook's GraphQL, was open sourced. And GraphQL, to me, I started this because I'm always looking for systems with the lowest total cost of ownership. It's like I want to write the least amount of code, I want to do the least amount of administration, and I want to pay the least amount. And Lambda offered that out of the box, but Lambda with GraphQL also seems to be incredibly efficient because you could take Facebook's GraphQL and node module and put it in a Lambda function and put GraphQL in front of infinite DynamoDB tables, for example, any type of data source. You could take that Lambda function, hook it up to a single HTTP endpoint, and then whenever you hit that and you make this, you'd essentially be making a Graph API. In your request to that Lambda function, you can request any data records across multiple data sources, or in this case, DynamoDB tables, and also any specific attributes of those of the data that you've queried, all in the form of this custom shape that you're requesting. So you can hit this single endpoint, and it'll trigger your Lambda function to execute. It hits GraphQL. GraphQL looks at the custom shape of your request. GraphQL will go out and query all of your data sources concurrently, bring in all the resulting data, and reshape it to match your request, and then spit that back out. And what that offers you is the potential to take a REST API, which may have up to 100 endpoints or something like that, and aggregate them or consolidate them all into this single Lambda function with a single HTTP endpoint. And to us, that just seemed radically efficient. But the problem is that because you have this one Lambda function that is in charge of all your reads and writes, it gets a lot harder to debug, but it's also a bit more challenging to fit in additional business logic. And so, we have a serverless GraphQL open source project in our GitHub account. It's just github.com/serverless. And just look through our projects. You'll see the serverless GraphQL boilerplate in there.
So that is fascinating. So my understanding of how GraphQL works is you have a server, a GraphQL server, where if you make a request, if any client makes a request for data in a database, for any of the databases that you have, you can make a request in the same pattern, just this easy to read JSON pattern, to the GraphQL server, and the GraphQL server makes the request to your different databases. It translates the request to, if you have a NoSQL database, it makes the request in that format. If you have a MySQL database, it makes the request in that format. If you have some other database, if you have a Cassandra, it makes the request in that format. And the purpose of the GraphQL server is that it unifies your data model from these different services so that the client-side programmer doesn't have to think about making a request in a specific format to a database. And if I explain that correctly, what you're saying is that it makes a lot of sense to throw this GraphQL logic in a Lambda function because it gets ad hoc requests, but it gets frequent enough requests to overcome the cold start problem.
Right. At the end of the day, it's just radical efficiency. And it brings for me it brings us closer to that lowest total cost of ownership.
So explain why we want to do that rather than just having a server that's always up. Because if I'm Uber or Facebook or any of these companies that has regular requests, there's always requests happening. Why don't I just leave a GraphQL server up all the time, or a container, and I have auto-scaling containers up and down? Why do I need Lambda?
Because Lambda offers, zero administration, and it's those three reasons I mentioned before. It's zero administration, better pricing model, much more efficient pricing model, and it's inherently sort of a microservices, which is based, which leaves you in a much more agile position. You could build this on servers or in containers, but Lambda, offers all that out of the box with those benefits. And again, if we can make this work, we're still messing with this pattern, which again, we're calling this the new monolithic pattern. I don't know if this is this is the best term.
It's not very sexy.
No, I mean, we're trying to put the word new in front of it, but monolithic has this horrible connotation these days. But it's radically efficient. Being able to reduce your REST API endpoints and putting it in this compute service that is sort of set it and forget it, and you deploy it. It's up there. It scales automatically. You don't have to configure that at all. You may have to contact AWS to get your concurrency limit raised, and you only get charged whenever it's executed. To us, to me, that just seems just so efficient. And what's driving this, of course, and what I see, I'm still new to the Bay Area. I've been up here for about 2 years, but what I see these days are just hyper competitive times. I see fast moving markups full of startups. There's just a ton of fragmentation these days. It seems like every single feature has become its own product. And then also increasingly lean enterprises. So we have these huge companies, these huge infrastructure as a service providers like Amazon and Google, who have adopted a lot of the agile methodologies of startups, and they're moving faster than ever, and they have tons of resources. So I see this age of hyper competition, also greatly accelerated by the fact that we're building software faster than ever. Everybody's practicing continuous delivery. Everybody's breaking up their monolithic applications and teams to microservice apps and teams. And at the end of the day, I think that Lambda offers people a competitive advantage right now, which is what we're all looking for, and is what we all need so desperately, because it frees you up, it frees your engineering resources up to do other things and really focus on the business logic. And right now, we're quick to adopt it. I was quick to adopt it because I'm half entrepreneur, half engineer. I'm always looking for that great competitive advantage. And I think for people who are adopting Lambda today, you will get that. I think in the near future, though, it's going to be table stakes. I think everybody will be doing this or be using something very similar to Lambda.
Okay, so the thing about Lambda that I have trouble connecting the dots on is it is, to me, this extremely transient thing. You make a single request, you make a request, it spins up a thing, and it spins up a black box, probably a container, on Amazon servers, and then it stays up for a little bit, and then it shuts down after a while. But many of the applications that we write are stateful. I mean, if I'm on Uber, I request a ride, and then I'm in the car, and I'm driving, my driver's driving me from point A to point B. It takes 15 to 20 minutes. I need that server to stay up to manage my session because I'm in the car still.
Right.
I need the service to not shut down while I'm still in the car.
Yeah.
So can you help me connect the dots here? How does a Lambda service account for that kind of non-transient use case?
Right. Lambda, there is still there are not as many options for managing state in Lambda right now. A lot of people are just relying on DynamoDB because it works very well with Lambda out of the box. You can manage a state. You put a state in DynamoDB, and then when the user session is over, you just remove it from the database. Yep. Other people,
Fascinating.
Other people are using, they're using Cognito. Cognito has great integration with Lambda.
What is Cognito?
Yeah, and I'm not a Cognito expert. I haven't used it.
Is that an Amazon service?
Yep, one of many. So people are using Cognito. They're also using Auth0, and how people are
Cognito. I get it. So that's like identity or something,
right? Yeah. And what a lot of people are doing is with Lambda and API Gateway has this new custom authorizers feature. And what this allows you to do is you could create one Lambda function that handles authentication or authorization or just checks the state. And you could have this Lambda function fire whenever someone hits one of your endpoints. If you set this Lambda function as the authorizer, you could have this Lambda function fire, do some type of authorization logic, and then call a second Lambda function right after that. So that's helping people manage state. It's helping people manage permissions and everything. And whenever that first authorizer function fires, you could set caching on that, so it doesn't fire all the time.
Software Engineering Daily is growing. More than 10,000 people listen to Software Engineering Daily every day, and I take that as a sign that this is something unique that people value. I am expanding the scope of the project, and I want to get other people involved. Send me an email at softwareengineeringdaily@gmail.com. I'm looking for new hosts, and I'm also looking for engineering and design help to help build a better website to host this content. Once I have a better site, the podcast can expand beyond audio content and into written word. If you're like me, you are not satisfied with the quality of material online about software engineering. If you have any suggestions or comments about what you would like to see more of on Software Engineering Daily, what you would like to see Software Engineering Daily evolve into, send me an email. I'm also looking for sponsors. If your company would like to support Software Engineering Daily, please send me an email at softwareengineeringdaily@gmail.com. There's advertising availability, and there's also other ways to support the show. Just send me an email if you're interested. Today, the show is generating enough money for me to make this a full-time job, but I would like to increase the cash flows so that I can reinvest that money into projects related to Software Engineering Daily. It's been almost a year since I started Software Engineering Daily, and I'm incredibly thankful that the listenership and the support has turned this into a sustainable business. If you are ever dissatisfied with the show, send me an email, send me a Slack message, send me a tweet, let me know what I can do better. And as always, thanks for listening to Software Engineering Daily. So to talk more about the actual plumbing that we are using to construct our serverless services, the Amazon API Gateway, which you've mentioned a couple times, it's a service that allows developers to maintain APIs. Explain what the Amazon API Gateway does in more detail. What are the benefits that the Amazon API Gateway provides?
Sure. I think in microservice architectures, there's been this long-standing idea of the API Gateway service, I guess. And anyway, it's one location where all of your where you can set up your HTTP endpoints, you can set up a REST API. And what AWS offers you here is kind of like a serverless implementation of this API Gateway. It's something that's completely managed for you. You only get charged whenever it's used, whenever your endpoints are called. You can set up caching on it very easily. You can set up any HTTP endpoints very easily. You could have those endpoints integrate with Lambda functions, so they could point to Lambda functions. They could also just be proxies. They could point to any outside service or any other AWS service. It's very easy to configure. Furthermore, there's a great staging feature in there, which allows you to have multiple, basically like environments for your API, which you can hook up to Lambda functions that may also have separate stages as well. And there's a lot of great agility there. Again, it's fantastic. It's just sort of set it and forget about it. You don't have to maintain it at all. But it's also great in that you could change each individual endpoint to point to any Lambda function that you want at any time, and even change each endpoint to point to Lambda functions in different stages. So you might have a Lambda function that's in some type of beta stage or something like that. You could easily just say, hey, let me change this single endpoint to point to that beta Lambda function, and we'll test it. If it doesn't work, we'll point it back to the older version of the production Lambda function. So it's nice, again, totally managed, leaves you in a very agile position. And super powerful. There's also a compute layer built in there, so that you could transform the types of requests and response that are going in and out via the Velocity template language. But a lot of people, API Gateway comes with a lot of power, a lot of functionality. A lot of people, it might be a bit too much functionality for people. And I will say that it was one of the main reasons why I started JAWS, which is now called the Serverless Framework, back in almost a year ago.
Which we should start talking about. So in 2015, you gave a talk at the AWS reInvent conference about this framework that you built called JAWS. And this eventually became serverless. So tell me about JAWS and why you started building that.
Right. So I was a huge Lambda fanboy as soon as it came out, and I was waiting for API Gateway to come out forever because I wanted to build everything on Lambda immediately. I said, I want to.
What kinds of? Can you tell me some of the applications that you were building with Lambda?
Oh, sure. I moved up to San Francisco because I wanted to do startups. I'm just sort of a purist entrepreneur. I came up here with a startup. And again, I'm just looking for competitive advantage. I'm looking to move faster always. And when Lambda came out, it really spoke to me in that regard. So what I needed to build, what I wanted to do was just refactor my entire application to run exclusively on Lambda and API Gateway. So I wanted to refactor the entire REST API to run on Lambda.
What was the app that you were working on?
The app was called Servant. It's a personal database for everybody. So the concept is that people have their own databases, which they can connect to the apps that they use, and those apps can they handle authentication, and those apps could quickly gain access to their data in standard formats and put that data to use right away. So very REST API centric. And when Lambda came out, it was clear. I said, "Oh, this is it. This is going to help us move so much faster and make it so much easier," because we had a really small team. And so I waited for API Gateway to come out. The day that it came out, there wasn't a lot of great documentation. I think they pushed it out pretty quickly. So anyway, the day that it came out, I started to refactor my startup to run exclusively on Lambda and API Gateway. I made my first Lambda function and I hooked it up to API Gateway all through the AWS dashboard, and it was amazing. It was I felt so powerful for only a few minutes until I started making more Lambda functions for other REST API paths and methods. And as soon as the first Lambda function was amazing. As soon as I got to 5 or 6 Lambda functions, building all these through the Amazon dashboard, it was clear that it was becoming there was a huge management problem here. There was no structure. Again, I was creating all these separate services. I wanted to share code across them. I wanted to deploy them more easily. I wanted to test them more easily. And all of that was super complicated. Again, Lambda is this microservice platform. But I think, the way that people are writing Lambda function code today is they're writing very job-focused, singular job-focused code in their Lambda functions, which is resulting in a lot more Lambda functions in their architectures, a lot more than I'd say that even microservice architectures would have. So I think with Lambda, you'll have more Lambda functions than you would have in a traditional microservice architecture. So I think New Relic, I think they have about 300 microservices that they use. I know Netflix has over 1,000, I think. And so if you think about if I think about what these companies would look like if they were all built on Lambda function, I would
the Death Star.
Yeah, I would say, wow, these would be several thousand Lambda functions most likely.
The Death Star exponentiated.
Yes, exactly. And so if you want to build a complex system with this amazing technology, it's really the compute service of the era. But if you want to build something complex on it, you really need a tool to handle that complexity. Lambda has, it solves a lot of the microservice problems, but it's also still inherited.
So without a framework, you're managing this stuff through the Amazon dashboard?
Yes, exactly.
Which is if you've never used the Amazon dashboard, this like crazy cluttered thing, right?
Crazy cluttered thing, just separate, a separate dashboard. They treat every service as totally disjointed. So you go over here for your Lambda functions, you go over here for your API gateway endpoints. You go over here to CloudWatch to see logs and stuff. And there's no unity there. And when Lambda was first coming out, I read some great articles. There was a great article called AWS Lambda as a Masterstroke by this guy named Janet Kiram, who's now an advisor of our company. Because I said, man, you're doing the most original thinking in this space. I really want you to be an advisor for our company. And he said, okay. But he wrote that Lambda would be the focal point of AWS Cloud in the future. And that is that everything that you build on AWS may use Lambda as the foundation or the compute service in the future. And I thought to myself, there's got to be a tool that approaches Amazon from that same perspective, as that Lambda is sort of the foundation of everything. And you should be able to just list out all your Lambda functions for your project, your application in one place, and then sort of pile on, okay, this Lambda function has this many endpoints, this Lambda function uses a couple DynamoDB tables, and everything should sort of be built on top of that. So yeah, the framework handles everything: automation, optimization, creating scaffolding, and just tons of best practices out of the box. You go on AWS and you read their documentation, which there's a lot, and it's pretty confusing.
Well, so help me understand how I get started. So if I'm like, okay, I want Lambda from day one, or maybe I want to onboard with Lambda from my pre-existing architecture.
Yep.
And I want a more usable way of interfacing with my services and updating them. So I want to use JAWS, now called Serverless, which is your framework. What do I do to get started, and how am I looking at this more visually appealing, more digestible form of representation for these different Lambda functions? Do you provide is it a web API, or is it like a configuration file that I have locally? Or tell me how I get onboarded and what the experience is, how it compares to managing all these Lambda functions through the janky AWS dashboard.
Right. Yes, the framework is a CLI tool. So command line interface that's built on Node.js. You must have Node version 4 installed, and then you can install the framework via npm. Just do npm install serverless with the global flag. And then you'll have a bunch of commands there that you could use to create a new project, to create Lambda functions in that project. And there's just, the CLI is just filled with functionality. It'll prompt you for all of the necessary information that it needs. It's going to need some type of access or API keys or session token to your AWS account. And once you add that in, and it'll prompt you for that right in the beginning, you can get started. And there's a few, let's see, on the GitHub repo, we've listed a few projects. So one thing we did with the framework is we made projects shareable. So, you could either create a new project from scratch using the CLI, or you can install a pre-existing project. And there are a few boilerplate projects that give you best examples and that you can install to get up and running more quickly.
Okay, and as I understand, with serverless, you have these things that are called AWS modules, and it's kind of like the modularity that you get maybe from Docker Hub, where you can just pull down this Docker container, and now you've got a way to run MySQL in your environment. Is that accurate? Is that your AWS module setup in serverless?
It's not. It used to be accurate, but we've stopped supporting the AWS module project just because it wasn't right. We never quite solved the problem that we were setting out to solve with that, and we've done a bad job of putting that it's unsupported now on the repository. So we have to do that. That one of the problems that I really wanted to address with the framework was that I think with this job-focused code that we're writing for Lambda, it's resulting in this great granularity, which I think could translate well to great reusability. And I thought, if you look at all the logic that we're building with our applications, there's a lot of custom logic that is specific to our business needs and requirements. But there's also a lot of common logic. It's stuff that we write and rewrite for every single application we make, like sending a transactional email or resizing an image or replicating data across regions. And I see Lambda and containers, with both of these forces. I think that we're on a brink of a dry revolution, and somehow we're going to be able to write this stuff once and have a greater level of reusability. And so the AWS module format, which is abbreviated as Austen, was our attempt to try and make Lambda functions, just have pre-written Lambda functions that are open source, and people can install them and deploy them right away without having to do anything. So we tried approaching the problem a few different ways. We never quite got there, but now we're working on Serverless Framework version 1. And we're attacking this problem again. We're coming at it with some new ideas. We're going to call these serverless services instead of AWS modules, because a big feature of version 1 is that now there's all these new serverless compute services. Since Lambda came out, we now have Azure Functions, Google Cloud Functions, IBM OpenWhisk Actions, and the story of the serverless framework is going to be to support all of these services in the framework. So you have flexibility about where you're going to deploy your code, and if there's any way that we could offer that code to be pre-written and easily installable and reusable, well, that's just something that I'm personally very passionate about, and I think we're very close to that. So we don't support the Austen format, but we're going to approach it again in version 1 with this new name, and it's going to be called the serverless service.
Is the business model for serverless to provide a layer of interoperability with all of these different Lambda function things? Like you can, like, let's say I have an application, and I write it using the serverless framework. Now my application is interoperable with AWS Lambda and IBM OpenWhisk and Azure Cloud Functions and Google Cloud Functions, and I can just take the best price from these different services based on just the fact that I've unified my model through serverless. Is that the business model?
Yeah, that's part of the value proposition. That's a big part, especially in this upcoming version 1 of the framework. As far as the business model goes, we have other projects, other commercial products that we'd like to launch. We're going to keep the framework free and open source forever, and just build other products around it. Because I have I think we have like 40 different serverless themed projects that we want to build, all heavily related to the framework. So that's how we're thinking about making money. But as far as what the biggest value you get out of the framework, and especially version 1, it's going to be interoperability with all those, and I guess we're using this term, functions as a service services, which are new and have just come out, and they look great. They have a lot of interesting stuff to offer. On the surface, they all look very similar to Lambda, but once you do a deep dive, they certainly are a bit different. And it's a little frustrating, but we've been working closely with Chris at Azure Functions, with Jason at Google Cloud Functions, with Steven at IBM OpenWhisk, and these people all have great ideas about these products and how they should be built. And it's frustrating on one hand because I'm thinking, our team is going to have to abstract all this. and figure out how to provide a uniform experience across all these different products. But at the same time, where these thought leaders, these team leaders are taking those products is just super interesting.
Well, and not to mention, isn't Amazon, like, they have no desire to be interoperable with these other things, right? Because they don't want the switching cost to be zero.
Yeah, I can't speak for them. I've got a great relationship with the Lambda team, with the API Gateway team. They've been over backwards to support us in so many different ways. As far as what they want to do, I know, Tim Wagner, the mighty Tim Wagner is leading both Lambda and API Gateway products over there at Amazon. He's been talking about interoperability. We've been chatting about this behind the scenes for a little while. He seems more open to it than I initially expected, given Amazon's track record, but also given their position as sort of the market leader. How this shakes out, don't know. It's still early days, but I don't know. I got to give it up to the team over there, because they've been great, embracing the open source community, helping everybody out, talking to their enterprise users. I'm always shocked at whenever I hear that the Lambda engineers have been talking to every single company that we're talking to. I can't believe they get any work done at the end of the day. So I don't know. I have high expectations for them, and I've seen good stuff. But we'll see. We'll see how this shakes out in the near future here, I'm sure.
So help me understand what that interoperability building process is like, because you've got AWS over here, you've got Google over here, you've got Azure over here, IBM over here. You want to write serverless in a way that I could deploy my serverless service and it's compatible with these different things. What sort of API do you have to provide as serverless that will be compatible with all of these different things?
Yeah, first step is defining a standard configuration format that works across all these providers, not just the big providers, but the little ones too. There's other companies like Iron.io who are doing lots of interesting stuff in this space. So coming up with this standard configuration format is something we've been chatting with AWS about, actually. And how this will be open to everybody. There's still some challenges there, especially because the other products that are Lambda competitors haven't officially been released yet, so they're still going through some big changes. We're trying to chase down those changes. But I think it starts with this standard way of describing the serverless application or the serverless service. And that's where we're going to start. Something that we've done with the serverless framework, which I think has been incredibly successful, is that it's completely extensible. To me and to my team, a great developer tool is like 100% hackable, because we're hackers. We like to go in there and change stuff. So anything that the framework does, you could write a plugin to overwrite that action or add in a new action. And with version 1 of the framework, we're doubling down on this core plugin architecture. And any provider is going to be able to build in plugins that offer a single deployment experience, or that add to the deployment experience to cover their provider.
So Amazon recently released something called Flourish, which is a runtime application model for AWS Lambda. I don't know much about Flourish, but maybe you've looked into it. How does Flourish compare to serverless?
It's hard to talk about, because we just learned about it a couple days ago, and I think Tim only really released like a single slide or 2 slides on it over at Serverless Conf last week. So we're still learning about it. It's clear, they want to collaborate with us. We've got a lot of momentum in the open source community. They want to collaborate with us and build this thing together. I don't know what it's going to turn into. It's still pretty early. But I don't know. Maybe we should revisit this conversation in a few weeks or a few months or something. We'll see. But we've recently got some funding, and by some great investors. We're going to do a formal announcement sooner. We're going strong with this multi-provider approach, which I think is the way to go. Developers should be free to use.
It has been the dream for many years.
Oh yeah, the developers should be free to use anything they want to take advantage of lower cost of compute or features. And this is the direction we're going in. We're going to work closely with Amazon as always, and also double down on our basic Amazon functionality. But now we're working closely with these other providers, and there's a lot of interesting stuff out there. And that's our direction. We've got the resources now to focus on this for a long time. And lastly, it's interesting when you think about what we're building here. This network of logic. I see these architectures as just this network of these little pieces of granular logic, all connected by events. And where that logic is located, those little tiny bits, I think it'll be less relevant than it was in the future, or less difficult to have some type of multi-cloud architecture than it was in the future, because we're not talking about having huge monolithic apps across different clouds. We're just talking about having little bits of code across these different clouds. And I think there's a great opportunity for that in this serverless event-driven architecture, to be able to take advantage, to use cloud functions to take advantage of some great data processing tools that Google offers, or to use Lambda to take advantage of some features that AWS offers, and have that event-driven code sort of work together seamlessly through some type of standard event format.
When I try to think about how these different compute platforms are positioning themselves against each other, it's very hard for me to project how it's going to look in the future. Like AWS, Google, Azure, are they going after the same markets, or are they going after disjoint markets? Is it like, they're just going after the same people, or is Google going after machine learning, and Azure is going after enterprise, and AWS is going after, I don't know, startups or I don't know. Like, right. Are these going for distinct verticals, or are they highly competitive with one another?
I see them as highly competitive. I see certain people are in the lead in certain areas. But I see as they all these are winner take all markets, and I think that these companies have a ton of resources that they're throwing at just about everything.
You do think it's winner take all? See, because I find that surprising, because like Google is going to win the machine learning market with TensorFlow, and Azure is going to win the enterprise market because they're already locked into Windows and the Microsoft ethos. Probably the same is true for people who are locked into Amazon Redshift or whatever Amazon's APIs are. Isn't there some degree of highly verticalized specialization? Maybe there is, and maybe this is what this serverless event-driven, microservice architecture will help with. But it's when people ask me like, what's the big value of Lambda? It's those reasons I mentioned, but it's also the reasons that Lambda works so well with all of AWS's other services, and that brings a lot of value to Lambda. How easily you can interact with DynamoDB or S3 in a really at really low latencies. So I see the value as transitioning to building out these as platforms and being able to offer everything on your platform and have it integrate very well together. So I really don't know. It could shake out, like you said. And again, I think the serverless, event-driven architecture may help that happen if we could use this as a way to connect clouds, and the developer could take advantage of all the features that they want. Don't know yet, but it's something that I kind of just want to get a bucket of popcorn and sit back and watch, because I think it's going to be interesting. I mean, these are truly titans battling it out. Indeed. So as we begin to close off, you mentioned the open source momentum of serverless. You mentioned the fact that you guys have gotten funding. give me a projection for how serverless is going to evolve in the next year or two, and your interaction with the open source community and how you are going to use that funding.
Right. Great question. First off, the framework is our core focus right now, and going multi-provider and offering this great uniform experience across all the clouds, and just making a great self-sustaining community. I think that's the most important thing. We'd like to work with enterprise companies. We've got a lot of great enterprise adoption already, which is shocking to me how fast these enterprise companies have adopted Lambda and the framework as well. But most of our focus is going to be on the framework. With this seed round, we'd like to introduce a few commercial products. The framework really only tackles the first half of the story, I'd say, and that is the development and deployment phases of building your application. Now, once you get something up and running on the internet, there's really nothing there that helps people understand what the heck their architecture looks like and how it's working together. So we see a lot of demand for that right now, and a lot of demand in other places. So, we'd like to focus on the framework, and we'd like to focus on that second half of the story. And I'd say probably the next year out, we'll be focused on just telling that full story, so that people can really build more complex systems on this, and everybody can adopt it.
Okay, Austen. Well, this has been an awesome conversation. I'm really happy to have had you on the show. Serverless is something that people are definitely excited about, both in terms of the branding, the actual branded product that you have, and serverless computing as a concept, the Lambda stuff and everything else. So thanks for coming on the show.
Hey, thanks for having me, Jeff. Would love to chat again anytime.
Absolutely. Okay, cool. Well, let's keep in touch.
Sounds good. Take care.